Bright Tuty. Every student matters.
Hello students, in the previous session we have seen how an algebraic expression is formed, and then we have seen what are the terms of an algebraic expression, and then what are the factors of a term of algebraic expression, and then we have seen how to find coefficients of any term in an algebraic expression. Now in this session we are going to discuss about like and unlike terms, and then we'll try to classify different expressions based on number of terms. Now when do we call two terms as like terms? So two terms are known as like terms when their algebraic factors are exactly same. So let's take two terms. For example, we are having 2xy and then 10xy. Now these are the two terms. What are the factors of first term? Factors are 2, x and y. These are the three factors, and out of these three, algebraic factors are x and y. Algebraic factors means factors having variables, and then the second term, here it is 10xy. What are the factors for this term? They are 10, x and y. Now again here also algebraic factors are x and y. Now as we can see, these two factors or the algebraic factors of both the terms are exactly same. Then it means we can say terms are like terms, or we can say 2xy and 10xy are like terms. So for checking whether two terms are like or not, what we have to do, we have to write their factors, and then we will check whether their algebraic factors are exactly same or not. Now let's take one more example. Suppose we are having 2y square x, and then the second term is 10y square x. Now here, what are the factors of first term? Factors are 2, y and x. So these are the four factors. Now for second term, factors are 10, y, x. Now algebraic factors are y, x in the first term, and in the second term algebraic factors are y, x. So it means again they are exactly same. So algebraic factors are same. It means terms are like terms. Now let's take one more example. Suppose we are having 20 x square zy, and then the second term is 5 zx square y. Now what do you think about these two terms? Are they like terms? What we have to do, we have to write their factors first. So for first term, factors are 20, x, z and y. So these are the factors of first term. Now let's write factors of second term. They are 5, z, x and y. Now if we will observe carefully, algebraic factors of both the terms are exactly same. They are xx, zy, and here also it is xx, zy. So it means again algebraic factors are same. Hence we can say terms are like terms. So this is how we check whether the terms are like terms or not. Now if the terms are not like terms, they are unlike terms. We can have example for that also. Let's say we are having 2xyz, and then we are having 4x square y. Now what are the factors here? Factors are 2, x, y and z. So these are the factors of first term, and factors of second term are 4, x, y. Now what do you think about their algebraic factors? Are they same? No, they are not same this time. As we can write here, not same. If algebraic factors are not same, it means terms are unlike terms. Now let's take one more example. Let's say we are having 2x square and then we are having 3x. Now what do you think about these two terms? Here term is 2x square, so factors will be 2x and x. So these are the factors of first term, and for second term factors are 3 and x. These are the two factors. Now what do you think about their algebraic factors? Are they same? Here we are having 2x, but here there is only 1x. So it means again they are not same. They have to be exactly same. Here variable used is same, but number of times the variable is coming is not same, because here we are having 2 times x, but here there is only 1x. So again these two terms are unlike terms. So for checking whether the terms are like or not, what we have to check? We just have to check whether their algebraic factors are exactly same or not. They should have same variables, and the number of times variable is appearing, that also should be same only. Now let's see one more example. Now let's try this question. Group the like terms together from the following. So here few terms are given, we have to group like terms together. So the first group will be, let's say the first term is 12x. Now which are the terms here which are like terms with 12x? The first one will be minus 25x, as the variable term here is x, or we can say the variable factor or the algebraic factor is x only. So it means the second term is minus 25x, and then we will have the term x. Here the algebraic factor is x only. So these are the 3 like terms. Similarly, we can have another like terms also. Let's say the second group. In this we are having minus 25y. So minus 25y, and then it will be 12y, because the algebraic factors are exactly same. It is y in both the cases, and then we will have y. So these are the 3 like terms, and then after these we will write all the constants, as all the constants will be again like terms. So it is 12 minus 25 and 1. So these are the groups of like terms. Now let's see how we can classify algebraic expressions based on their number of terms. So based on number of terms, we can classify algebraic expression in monomials, binomials, trinomials and polynomials. Now what are monomials? Algebraic expressions having one term. Algebraic expressions having one term are known as monomial. And then we are having binomials. Algebraic expressions having two terms. Two terms means two unlike terms. By two terms, here we mean two unlike terms. If an algebraic expression is having two unlike terms, then it is binomial. Now by the name it is clear what are trinomials. So trinomials means three terms. Three terms means three unlike terms. If an algebraic expression is having three terms, then it is known as trinomial. Now what are polynomials? So it is algebraic expression having one or more terms are known as polynomials. So broadly we are having these three categories: monomial, binomial and trinomial, and all these are polynomials only, because polynomials means algebraic expressions having more than one or more than one terms. So these are all polynomials only. If an algebraic expression will have 4 terms, then it will be a polynomial. If it is having 5 terms or say 50 terms, then also it will be a polynomial only. So algebraic expression having one or more terms is known as polynomial, and specifically if it is having only one term, it is known as monomial. If it is having 2 terms, then it is binomial, and for 3 terms it is trinomial. So this is how we can classify algebraic expressions based on their number of terms. Now let us see few examples based on each category. For first, monomials, we can have expressions with only one term. Let's say we are having 7x. So here there is only one term, 7x, and then we can have 8xy, and then let's say we are having xyz, and then we can have x plus 7x plus 8x. Now how many terms are there in this expression? See, in this expression there are 3 terms, or it is only one term. It is basically only one term because all the terms are like terms only. This can be written as equal to x plus 7x will be 8x, and 8x plus 8x it is 16x. So this is nothing but 16x. So this is also example of monomial. And let's say we can have 8, 10, 19, 17. All these are also examples of monomials. So these are few examples of monomials. So monomials are basically algebraic expressions having only one term. Now let's move to the next part, and that is binomials. As we have seen, algebraic expression having 2 terms is known as binomial. So suppose we can have x plus y, x plus 7, xyz minus xy, 7x square plus 2y square. As we can see here, in every expression there are 2 terms. For x plus y, 2 terms are x and y. For x plus 7, 2 terms are x and 7. And then we are having xyz minus xy. Again there are 2 terms. And then 7x square plus 2y square. Again there are 2 terms. So all these are examples of binomials. Now let's suppose we are having this 7 plus 8. So is it a binomial? No, it is not a binomial because these 2 terms are like terms only. We should have 2 unlike terms, then only it is a binomial. So here 7 plus 8 can be written as 15. So there is only one term. So this is monomial. This one is not binomial. Now again let's say we are having 8x square plus 10x square. Now what do you think about this expression? Is it a binomial? Do we have 2 unlike terms here? No, we don't have 2 unlike terms. These are 2 like terms only. So again this is also example of monomial only. It is not binomial. Now suppose we are having 10y square zx or 10y square xz, and the second term is 2zy square x. Now what do you think about these 2 terms? Here algebraic factors are y, x, z, and here also it will be y, x, z. So basically what we have to check is, we just have to check the variable terms, or we have to check the variable factors here. Variable factors are x, y and z, and here also x, y and z. And then what we have to check? Then we have to check their powers. If variables are exactly same, then we will check their powers. And if their powers are also exactly same, then it means terms are like terms. So here also these 2 terms are like terms. So if we will form an expression like this by adding these two terms, then it means this is a monomial expression. It is not binomial because both the terms are like terms here. So for binomial we should have two unlike terms, then only an expression is known as binomial. Now let's move to the third category, it is trinomial. Trinomial means we should have three unlike terms. So let's say we are having 3x plus 4y plus 5. Now how many terms are here? Here we are having three unlike terms. The first term is 3x and then it is 4y and then 5. Similarly we can have 4x square z plus 4xy plus 4zx square plus 2x. Now is it a trinomial? Yes, it is a trinomial because here these two terms are like terms only. 4x square z and 4zx square. These are the two like terms only. So in this expression we are having three different unlike terms. We are having three unlike terms here. So it means this is also an example of trinomial. Now let's say we are having 7 plus 8 plus x plus x plus y plus y. Now what do you think about this expression? Is it a trinomial? Yes, it is a trinomial because here also we are having only three unlike terms. 7 and 8, these are two like terms, and then we are having x plus x, these are also again like terms, and then y plus y, these are also like terms. So here basically we are having only three unlike terms, so therefore this is also an example of trinomial only. Now to check whether a term is unlike or like, what we do, we just have to check the variables included in terms. If the variables are exactly same, then we will check their powers, and if powers are also same, then the terms are known as like terms. So basically two terms are like terms if their variable factors and powers of the variable factors are exactly same, then two terms are known as like terms, otherwise they are unlike terms. If two terms are not like terms, then they are unlike terms. Now let's try this question. The question here is, classify the following expressions as a monomial, a binomial or a trinomial. So here the first expression is A. So what do you think about this expression? Is it a binomial, monomial? Is it a binomial, monomial or a trinomial? So as there is only one term, so this is monomial. And then the second expression is A plus B. So how many terms are here? There are two terms, so it means it is a binomial. And the next one is AB plus A plus B. So here we are having AB plus A plus B. So there are three terms and all the three terms are unlike terms, so it means this is a trinomial. And then we'll have AB plus A plus B minus 5. So here we are having AB plus A plus B minus 5. So how many terms are here? There are four terms. So is it neither monomial nor binomial nor a trinomial? So what kind of algebraic expression it is? So we are having four terms and all the terms are unlike terms here. So it means this is a polynomial. We can classify it as polynomial. We can't say it as monomial, binomial or trinomial because number of terms are 4 here. And then the next expression is xy. So what do you think about this expression xy? As there is only one term, so it is monomial. And then we are having xy plus 5. So xy plus 5. How many terms are there? There are 2 terms. So it means it is a binomial. And then we are having 5x square minus x plus 2. So 5x square minus x plus 2. How many terms are written? There are 3 unlike terms. The first term is 5x square, the second term is minus x, and the third term is 2. So there are 3 unlike terms, so it means it is a trinomial. So to classify the expressions, what we have to do, we just have to check number of terms they are having, or we have to check number of unlike terms they are having. And after this expression, we are having 4pq minus 3q plus 5p. So 4pq minus 3q plus 5p. So how many terms are written? There are 3 unlike terms. So it means this is an example of trinomial. Now after this one, we are having 7. So as there is only one term, so it is monomial. And then 4m minus 7n plus 10. 4m minus 7n plus 10. So again there are 3 terms, 4m, and then the second term is minus 7n, and the third one is 10. So 3 terms means trinomial. And the last expression is 4mn plus 7. 4mn plus 7. So here we are having 2 terms, so it means this is a binomial. So here we have classified each expression as a monomial, binomial or trinomial. There was only one expression which was having 4 terms, and it is ab plus a plus b minus 5, this expression. So this was classified as polynomial, because polynomials are expressions which are having one or more terms. All these are polynomials only. Now let's try this question. The question here is, state with reasons which of the following pairs of terms are like terms and which are of unlike terms. So here few pairs of terms are given to us. We have to state whether they are like terms or unlike terms, and we have to give reasons also. So for this we can form a table like this. Now in this first column is, we are writing pairs which are given to us, and then we'll write factors of each term, and then we'll compare their algebraic factors whether they are same or not, and based on that we will state whether the terms are like terms or unlike terms, and then we'll give remarks in which we will tell why the terms are like terms or why the terms are unlike terms. So here the first pair is 7x and 12y. For the first pair we are having 2 different terms, like 2 terms are given, 7x and 12y. So what are the factors of first term? Factors are 7 and x. So these are the 2 factors of the first term, and for the second term it will be 12 and y. So these are the 2 factors for the second term. Now compare their algebraic factors. For the first term it is x, and for the second term it is y, and it means algebraic factors are different. So we will write different here. So in this column we have write different, and then what we have to do, we have to tell whether the terms are like terms or unlike terms. As we can see, their algebraic factors are different, so it means terms are unlike terms. And for remarks we can write algebraic factors or variables in terms are different. We can write variables in terms are different. Now the next pair is 15x and minus 21y. So factors are 15 and x, and for the second term it will be minus 21 and x. So now what do you think about their algebraic factors? They are same only. In both the terms they are x. In both the terms it is x. So it means algebraic factors are same. Hence the terms are like terms. And for remarks we can say their algebraic factors are same, which we have already written here. So no need of writing any other reason. And then we'll have minus 4ab. So factors are minus 4a and b. So these are the factors. And then second term is 7ba. So factors are 7, b and a. So here if we will observe carefully, algebraic factors are a and b in the first term, and in the second term it is b and a. They are same only. So it means we can write same here. That is, their algebraic factors are same, hence terms are like terms. And for remarks we can say AB is equal to BA, because we know A multiplied with B or B multiplied with A, they are same thing only. So it means the terms here are like terms. So here we have discussed about the first three pairs. We have discussed till here. Now we are having 1, 2, 3 and 4. 4 more pairs. Now let's discuss about them. Now here are 3 more parts of this question. Now the fourth part is 3xy and 3x. So we are having 2 terms. We have to tell whether they are like or not. So again we'll write their factors. For the first term it is 3x and y. So we will write 3x and y. These are the 3 factors. And then for the second term it is 3 and x. So what about their algebraic factors? Are they same? No, they are not same. They are different in this case, because for the first term it is x and y, and for the second term it is only x. So it means terms are unlike terms. So for remarks we can write variable y is factor of only one term. The variable y is factor of only one term, that is the first term. It is not a factor of the second term. Now the next pair is 6xy square and then 9x square y. So factors are 6, x, y and y, and then the factors of second term are 9, x, x and then y. Now what do you think about their algebraic factors? For the first one it is x, y, y, and then it is x, x, y. So again they are different. So it means terms are unlike terms. So here what we have observed, variables are same but their powers are not same. As we can see, variables in the first term are x and y, and variables in the second term are also x and y. But power of x is 1 in the first term, and in the second term power of x is 2. And for y, power is 2 in the first term and it is 1 for the second term. So it means what we can say, variables are same but their powers is not same. So two terms are like terms if the variables are exactly same and their powers are also exactly same. Now the sixth pair is p q square, and the second term it is minus 4 p q square. So for the first term, factors are 1, as we never write 1 if 1 is the coefficient here. So 1, p, q and q. These are the factors, and for second it is minus 4, p, q and q. Now again the algebraic factors are p, q, q, and in the second term also it is p, q, q. So it means here algebraic factors are same. It means we can say terms are like terms. So here what we have seen, factors of the first term or the numerical factor of the first term was 1, which was not written here. So here we can say numeric factor one is not written with the term. This is what we have observed here. So this pair is of like terms. Similarly, let's see the seventh pair also. It is mn square and then it is 10mn. For the first term, factors are m, n and n. M, n, n. And one of the factor is 1, as it is not written here. Numeric vector 1 we never write. So it is 1, m, n and n. And then for the second term it will be 10, m and n. So here variables are same but their powers are not same. So it means these two terms are unlike terms. So basically, for checking whether the terms are like terms or not, what we do, we check the variables included in the terms. If the variables included are exactly same and their powers are also same, then it means terms are like terms. We are only bothered about variables used in the terms. We don't care about the constants or the numerical constants or the numerical coefficients. They can have different powers also, they can be different also. We are not worried about that. We are only worried about the variables used in the terms or the algebraic factors. We call them as algebraic factors. Algebraic factors should be exactly same. Then only terms are like terms. And if the terms are not like terms, they are unlike terms. So in this session, we have discussed how to tell whether the terms are like terms or not, and then we have seen how we can classify an expression based on number of terms it is having. It can be monomial if there is only one term, it can be binomial if there are two terms and the terms are unlike terms. And then the third one was trinomial if there are three unlike terms in an expression. And then we have seen what are polynomials. Polynomials are basically algebraic expressions having one or more terms. So all these are polynomials only. So that's all for this session. Stay tuned for more upcoming videos like this.